Alrighty, so hello again, here we are. So the idea is that I like to restart the stream of each question. Here we are doing on audio. So the idea, audio is working, and I've got the chat. All right, this question is going to be number 1177, which is going to be, can make palindrome from substring on LeetCode. And it's going to be, I can make palindrome from substring on LeetCode. We'll get right into it. So, you're given a string S and array queries, where queries of I is equal to left sub I, right sub I, case sub I. We may rearrange the string S of left sub I, ... right sub I for each query, and then choose up to k sub I of them to replace with any lowercase English letter. If the substring is possible to be a palindrome string after the operations above, the result of the query is true, otherwise the result is false. Return a Boolean array answer with answer where answer of I is the result of the ith query queries of I. Note that each letter is counted individually for replacement. So if, for example, S left sub I ... right sub I is equal to A, and k sub I is equal to 2, we can only replace 2 of the letters. Also note that no query modifies the initial string S. Okay. Can make palette queries. Okay, it's an interesting question. I have to read it again. I don't totally know what they're asking. Queries of 0, D is palindrome. How am I doing? Yeah, okay. So D is palindrome, BC is not palindrome. ABCD is not palindrome after replacing one character. 330. I think I can use monikers here. 120. So true, false, false, true, true. Given a string S and array queries where queries of I equals left sub I, right sub I, k sub I, we may rearrange the substring. How many queries are there going to be? Oh wow, 100. The string is 100,000 and the queries are 100,000. Whoa. Excuse me. Oh, gee, I can hear yelling. Left sub I, right sub I, k sub I. S consists of lowercase English letters. All right. What do I have? So, gotta breathe. Let's see. Substring is possible to be a palindrome string after the operations above. The result of the query is true, otherwise the result is false. Given a string S and array queries for queries of I is left sub I, right sub I, k sub I, may rearrange the substring for each query and then choose up to k sub I of them to replace with any lowercase letter. Okay, I'm a little confused. Rearrange the substring for each query and then choose up to k sub I. Can you give me an example? Okay, here we go. So query 3, 0, 1, 2, 3. Sorry, my mind is kind of hearing yelling and doors slamming over here. My home life is not perfect. Just phrase it that way. One of the reasons why I try very hard, actually, is because if you make a bunch of money, you can kind of straighten out things at home. In theory, anyway. At least in theory. Shouldn't really be that way. It's a little more complicated, but that was kind of what I was going for in my life at one point. One of the things, but yeah, it's like I said, it's gonna be more complicated than that, I think, the issues, but we'll come back to those things another time. Those are more personal things. Anyway, so ABCD could be changed to ABBA, which is palindrome. Also, this can be changed to BAAB. First, rearrange it. BACD, then replace CD with AB. So I think this is just looking for an analysis of frequency maps, where if you have the, what's that called? If you have the right it's anagram. That's what it's called. Yeah, it's anagram. It's sort of an anagram analysis, which I should be able to do this actually in constant time per query, and yeah, per query, and should be able to set it up in linear time. constant time per query, and I can do a linear, set this up in linear time for the string. It will be, I think, linear times 26 for the number of lowercase characters, like so the linear times the size of the character set, but it should work for this question. One question is, yeah, I think the analysis they're looking for is something of an anagram. So they're saying, could you take this, what you've got, and change it to, change how many characters? It's 0, so 0, 1, 2, 3. We get 2 characters can be changed here. These could be rearranged. 2 characters can be modified though. So you can get, excuse me, A, B, B, A, and not move C or D at all, or B, A, B, flip A, B, and A, and also change this to A, B. Right. Okay, I think I understand the question. So yeah, the solution is going to be, it's actually pretty low submission rate acceptance rate. This I think is not too hard of a question. I could be wrong about that, but I think it's not too bad. I don't think you can do better than linear time, by the way. I'm pretty sure linear time is probably as good as it gets for this question. The way that you can analyze the anagram using the frequency map of the characters, and you could just use a like this is a range of characters, right? So 0 to 3, ABC 0, 1, 2, 3. It's inclusive. Yeah. I can just use prefix arrays of like character counts to perform the analysis of like how many characters of in constant time for a given query, what the frequency map of characters looks like. Should be able to do it in constant time. And the question is, once I have that frequency map and I have a given k, how can I determine whether it's true or false, right? I think, so I think in order to be a palindrome, all of the frequencies for each character need to be odd, or excuse me, even, that's a palindrome, or all of them except one is odd. Or excuse me, all of them except one, all of them are even except for one that is odd. Yes. Okay. So I can count the number of odd frequencies. If it's 1 or less, then it can be made into a palindrome. That's if k is 0. If k is 1, then I could take any one odd frequency and change the character to something else, which will make that odd one even, but some even one odd. Okay. So I can replace either 2 or 2 at a time, 2 or 0. And do I have to replace both characters or just one? Up to k sub I. So I don't need to use k sub I. Okay. So I think each k sub I, I can decrement by 2 odd frequencies. I think that's what I can do. Because if I take 2 even frequencies, then they just swap, right? And they're still both even. If I take an odd frequency and swap it into an even frequency, then I just swap odd and even, and I don't go anywhere. And then if they're both odd, it's the same thing. If they're both odd, they both become even. If they're both even, they stay even. I think actually if they're both even, I can make them both odd. If they're odd and even, it stays odd and even. So, yeah, I can create more, but I don't want to create more. I want to go down to 0 or 1. So I think what I can do is now, I can go 2 at a time downwards by k. So if 2 times k is greater than or equal to the odd frequency count, right? If it's equal, I can just subtract all those 2k. If 2k is larger, then again, if it's an even number, I can go all the way down to 0. If it's an odd number, I can go down to 1. And I don't necessarily use all of the k values. If it's 1 more than 2k, right, that also can still be a palindrome. So 2k plus 1 is the upper bound, right, for the number of odd values in the frequency. I think that's what I want. Right. If it's 2k or less, I can make it a palindrome. If it's 2k plus 1, I can make it a palindrome. And then k obviously is always going to be greater than or equal to 0. So yeah. So as long as this is the frequency amount is less than or equal to 2k plus 1, then I return true. Yeah, it should be pretty straightforward. This took me a while to explain all those things, think it all the way through. It took a few minutes, but not too bad overall. Not too bad overall. Let's do prefix array of size 26. It's actually going to be n equals s.size fill 0, I is less than 26. Prefix array of I fill prefix array of I plus n, I think, zeros. And for int I is 0, I is less than n, increment I. I'm going to say const char ch is s of I. Index is going to be ch minus a. And we're going to say prefix array of it's going to be it's going to be something like this. It's this is kind of awkward. Let me think about this for a second. There may be a better way to do this, by the way. Actually, there's probably a better way to do this. I think I just want to say prefix array of, this always has at least one character, right? Yeah, okay. Of s of 0 minus a increment of 0. Yes. Okay, everything else is 0. And I'm going to say for each j is 0, j is less than 26, increment j. Wonder if I should do it the other way around. I'm trying to think if there's a better way to do this. Doesn't actually matter, yeah. It does matter. It does matter how I loop through here. It does matter. I want to do the other way around. I and j on the other side. This does matter. How do I do this? Okay. So what I'm going to do is say prefix array of I. J is prefix array of I j minus 1 plus S of j is equal to ch is equal to ch. Okay. So it's going to be the previous amount, and then if I match on this particular index, okay, and if I match on this particular index, then I increment on that amount there. Okay, this is a little bit better. I think this works. Okay, that sets up the prefix arrays for the frequencies. Now for each query, vector and queries. So there's A is V0, B is V1, and C is V2, right? I'm going to get the frequency map. So int frequency 26. This actually should be done up here. I don't need to reallocate that every time. Okay, and let's start with filling this, making it empty. And then now I'm going to say for each I, 0, I is less than 26, say frequency of I is going to be equal to its prefix array of I of, it's going to be B minus A, right, plus, excuse me, it's inclusive, and in that case I actually want to add back like S of A, whether or not S of A is equal to this value of I. Yeah, a little bit confusing there. Hopefully it makes sense. So that is going to give me, like I was describing before. So it uses a difference between two prefix sums to get me the number of elements that match a particular character. So that'll give me the frequency for each character there. Then I'm going to want to get the count. Actually, I don't even really need that frequency, do I? I don't need that. That's not even necessary. Not even necessary. We'll just say int odd count. Odd count is 0. We're going to say frequency is that amount, and then odd count plus equals frequency on 1 tells me if it's odd or not. Now, my result is going to be a vector, full result, queries.size, false, return result. Actually, I could do just reserve. Okay. And just push back. This is going to be, I think I said before, odd count is less than or equal to 2 times k plus 1, which is just C, the shift to the left. Okay, something like this. This is kind of involved. This should be, I think this is what they want. I do it on time, almost 20 minutes. Okay, those look correct. I can do, it's a lot of, again, there's a lot of produce. I'm just gonna submit it. There could be some things that are wrong. Oh, nope, got it. All right. I was gonna say, yeah, I could do more. I could do testing here, but I just want to go for it. So great, that was the answer. That worked. There may be a more efficient way to do this. I'm sure there is, but this is reasonable. This is reasonable. The problem with this solution is that it's linear, but it's linear in terms of the size of the character set. So I'm multiplying sort of the character set times n, O of the character set size times n, which it probably doesn't have to be 1, 2, 3, 4, 5. Where's that 4? It doesn't. It probably doesn't have to be like that. It probably could be faster. Probably could be just linear time if I had to guess. Good chance it could just be linear time, but this is sufficient as it is. This satisfies the requirements. So yeah, thanks for watching. That's that one. I'm gonna go ahead and so if you like the video, give it a like and subscribe for more. And I'll go ahead and stop here and restart on another question. Stop the stream and restart another question.